What is going on, guys? It's Jake, aka StarCoding, here to talk about computer science. And more specifically today, we're going to be talking about DevOps, how to achieve a peak performing DevOps team. Your boy here is not a DevOps engineer, I'm actually one of the developers, but I was surfing the internet and found a nice study done by Humanitec here, done in 2021, just a benchmark studying 1,856 different organizations and how they do their DevOps team. And they have a bunch of metrics, a bunch of questions they asked all these teams, and we're going to dive into the results and find out how to make a top performing DevOps team. So guys, sit back, let's enjoy the show. So before we actually dive into the data, let's just look at who Humanitec is before taking their data at face value. Okay, we're not gonna just read this and assume it's factual. So first things first, they are hiring. If any DevOps engineer here needs a job, any developer, bam, go click apply. But they are a platform engineering team, and they're trying to revolutionize how teams build and run their cloud applications. They build internal development platforms, and they have tools to help DevOps engineers do their job. They have some products here, some for developers and some for the DevOps peeps. But if you're in the cloud, if you're making cloud apps, odds are Humanitec could potentially be sitting in between your CI/CD pipeline and helping you out along that road. So they want to sell us on the DevOps lifecycle. Let's just keep that in mind when we're looking at this data. Needless to say, let's hop in. So we're going to talk about some performance matrix of what makes a good DevOps team. Before though, just quick note, DevOps engineers, if you're confused of what they're exactly supposed to do, they are the people that do the operations side of development. You have application developers that are writing the code, testing the code, and then you have DevOps engineers that kind of automate and configure that code to work on a software system, on a cloud system, on an on-premise system, maybe some microservices, maybe some monolithic services, but you have programmers programming and you have DevOps engineers configuring to make that public facing. So that is, just to have a premise of what these DevOps engineers are doing. But we can talk about deployment frequency. How long does it take, the sprints, the features to get deployed to production? Lead time. How long does it take individual code to find its way to production? Mean time to recover. So if something happens, how long does it take to get back up? And change failure rate. How many bad snippets of code, how many buggy codes are getting uploaded to your production? So these are the 4 key metrics we're going to look at here. Let's hop into some charts. So here we are, we're looking at our first chart. We're talking about development frequency. How fast can I upload the code that I've made into an environment, into an actual machine? And the way that this is a little bar chart. So we have our top performers, our high performers, mid and low. It definitely sees that the high performers are able to, they're able to do their stuff on demand. As soon as a change is made, it can be deployed into an environment of some sort. High performing teams, several times a day. Maybe it's scheduled at 12 p.m. at 5 p.m. We're gonna push our code. Anything that's been changed, we will do this. And I kind of look at this a little bit with a grain of salt, because yes, if you're making something modular and microservice-y, then that's awesome. You're able to deploy frequently. If it's an older system with a bunch of users, legacy code, I could definitely see how maybe once a month is in, if the build takes like 24 hours to actually build, because some servers just, I don't know, they take a long time to build. But if you're making stuff like a React app, like simple Golang applications, by all means deploy frequently. But if you have a big system, I feel like yes, maybe these top performers that are pushing out monthly. Maybe that's why, because they have a big system. They don't want to have to worry about deploying that every day. It takes up a lot of resources. And the second chart we have is that lead time. So we have code coming from code to production. This involves, the coding, the testing, end-to-end testing, and all that jazz, all the way to production. 25% of organizations and those top performers, still that light blue, are able to do it in minutes. And I have serious doubts about that. Okay, code from code into production in minutes. I understand, yes, you could have some automation in between there to, get the code smells out of the way, and that this code is not going to break, it can build. But to test business logic in minutes, impressive. I have questions about that statement. But needless to say, it seems like getting code from a development environment to a production environment within a day and a week is 50% of organizations. So if you're not able to get your stuff from environment or from development environment to production environment within a week, you're slow. All right, pick it up. That's what it's all about. Some of these guys are taking between 1 week and a month. Yeah, 7.5 say it takes 1 month to get code from dev to prod, which must be excruciatingly painful. So, know where you are, make improvements. The next thing we're talking about is mean time recovery. How long does it take your system to recover once it fails? Because it's not if, it's when your system fails. That's the mindset. So, for these teams, there's kind of the key metric points were 1, less than an hour. Very nicely done, guys, saving all the money. Think of the last time you saw AWS down. If it's down, it is back up. I think in the example in this benchmark study, they were talking about a store that went down for 4 days. It was a big Europe retail store. Went down for 4 days, lost 12 million euros. Think about all the salaries that could have been paid, but they couldn't recover fast enough. So DevOps teams, this is a key metric. Getting back to recovery, and obviously you're striving for this. Less than an hour, that's awesome. Less than a day, I'll give it to you. I'd say that these are all pretty solid if you're getting it done, in less than a day. But those teams that take more than 1 day, the ones that say I don't know, we want to get that back up and running as soon as possible. To the next metric, and here we go. Here's our last metric, the change failure rate. So this is just looking at when you push code, is it going to break? Is it broken? Is it going to damage something? And for the most part, 78.2% of all the teams were able to get under 15% errors, which is great. We love that. For these teams out here that are getting 30%, 45% error rates, I suggest some more code review sessions and maybe getting some sort of automated testing integrated into your CI/CD pipeline. Always great for seeing if something is going to break your code. Never take someone's word for it. Even if they are a senior developer, always have someone else test and look at that code. So we looked at those metrics. We saw what some of the top performers were doing versus some of the lower performance people were doing. And let's look at some of the metrics of those teams. Like, is there something about the team that was making them better than the others? Well, for one, we can look at team size. And team size actually had no effect. So you can see that, the top performers are here on the right side of the screen. And we have our low performers over here. And you can see that these pie charts are almost purely similar. So team size is not going to affect how your DevOps team performs. And for the next guy, it looks like we're looking at the assembly of the architecture. And that just means, is it a monolithic architecture or is it a microservice? And this, chart makes it seem like, oh yeah, microservices are the way to go because our top performers were 95.5% loosely coupled, most likely microservices, while the low performers had 60% monolithic stuffs. And to this, I would say, okay, yes, if you're running on microservices, then odds are you're doing something new, something innovative, and maybe you have these automated tools at your disposal to where you can, get those deployment times under an hour. I feel like if you're developing a monolithic application, there's probably a reason. It's either legacy or there is a reason that it needs to be monolithic, and I could see why the deployment would be, slow on those. But it depends. It always depends if a monolithic or microservice solution is the right one to go to. Don't base it off of just your DevOps experience. All right. Now looking at the degree of containerization. So top performers are always going to have their services containerized. It doesn't seem like a lot of companies have half their services containerized. It seems like if you're going into the containerized, if you're going down that path, you might as well just send it and make all your stuff containerized. I, for one, also agree with this. This is, it's great for load balancing, for dealing with internet traffic's crazy loads. You just YAML, bam, push it up. Infrastructure as code. It is great. Starting to migrate, so that's great. No migration plans. It looks like probably, I'd say 15%-ish of organizations here are not containerized, but the rest of them are all planning on it, so that's great. One thing I also found interesting here is that it seems like Kubernetes has a freaking monopoly on orchestration tool of choice. 80% of top performers are using Kubernetes, and 56 of them here are using Kubernetes. It looks like Docker Swarm is a solid second place, but not by, it is a big margin lead. This is like watching some college football games when Ohio State used to destroy Big Ten teams. But yeah, that is orchestration tool of choice. Here we're looking at if people are hard coding their configuration variables or if they're having them in some stored environment where the DevOps team can make edits to it. So the top performers are using infrastructure configuration. This means that those config variables are most likely in a YAML file or most likely in some sort of cloud storage container. As well, the low performers, when it is no, is talking about it's just in the code. It's just in the code. Configuration there. And I would have to say that yes, makes it so much easier to change stuff on the fly without having to dive into the code. So there we go. And here we have it. So that was pretty much all the metrics, everything that was found in this case study. Out of all the organizations, they created this chart to kind of map where organizations are. And they call this the DevOps Mountain of Tiers right here because it's just where so many organizations are. And, we obviously probably want to get on the other side of this mountain. So how are we going to cross this DevOps Mountain of Tiers and get to the other side? Well, luckily, they talk about it as well. So I hate to be that motivational guy, but that's really what it's looking like it's going to be. To get past that trail, that mountain of tiers, we want our internal platform team, aka our DevOps team, to be product mindseted, to have a product mindset. The DevOps pipeline is not just, something that needs to get done. It is a product for your application developers. It's not supposed to be something cool and nice. It is supposed to be a product that is continually worked on to make the developer experience better. Yeah, I know the developer here is saying it, but it's also said here. So, whoa, don't come at me. And I think that is a cool mindset to have for a team. We're not making, this isn't just a part of the app that we're giving to the end customer. No, my job is to make the developer experience easy, so that way we can push our code quicker. Developers don't need to think, I guess, as much about the pipeline. They can work more on the business logic, which I want to say is something they talk about over here with cognitive load and cognitive load trade-offs, which is great. And essentially, what they're talking about is, do we even need a DevOps team on some projects? And the answer is, it depends. If the developers aren't being cognitively challenged, if the solution isn't complex, then a developer could probably do the DevOps project. But if we need a lot of abstract, complex code, that's when we need to get a DevOps team involved and let the developers work on that, while the DevOps team can work on getting it to production. As a quick side note before we end off, they were talking about this golden paths over golden cages, which I thought was fun. Essentially, we want to make a quick and easy path for developers to get their code from local dev environments to production, but we don't want to make it a cage. We don't want to make it some complex box of permissions and permissions before that code can get to production. There's a fine line between optimal and structured versus bureaucratic, and yeah, just bureaucratic. That's the word for it. Well, I'm going to leave it off at that, guys. Thanks for stopping by and watching this video. I hope that you're now able to take your DevOps team to the next level after watching this video. Hit that subscribe button. Leave a comment below if you have any questions about it. And by all means, thanks for watching. Peace.